the circle. Those angles that were central to the circle marked off an arc length. And today what we're going to start talking about is circular functions. In your calculator, you guys probably use the button sine, cosine, and tangent, right? How about the secant button? Have you ever used the secant button? Everybody use the cosecant button? Anybody use the cotangent button?
Yeah.
Or are they even there?
They're not even on.
Not even there. Okay, so we'll talk about what I'm dealing with here in a second. But guys, real quickly, these notes are good notes, but when you see this chart right here that I'm talking about, when you see this chart that I'm talking about right here, once you see that chart, where'd that original one go? Did you sit on my desk? Okay. When you hear me start talking about charting out values, this is the one that's going to be really important for you. Okay, so for instance, I'm looking at like, well, find 120 degrees. Do you guys see 120 degrees there on your chart? Go down the degrees column. This one here.
Yeah.
Go down the degrees column to 120 degrees. What's the sine value when you're dealing with 120 degrees? Root 3 over. How about the cosine value?
-1/2.
So you're okay to use. Nice thing about this is in degrees and in what? Radians. So this covers all 6 trig functions in one revolution of a unit circle. I think Nathan described it best when he said the unit circle is a circle where the radius is 1 everywhere. So let's go ahead and take a look at this goal and ask ourselves what we're doing. Guys, the goal in this today is to be able to look at the trig functions, sine, cosine, tangent, secant, cosecant, and cotangent. We can do these here by thinking about a point on a specific circle that's called, what's that name again? The unit circle, and knowing a relationship between sine, cosine, and tangent. We'll make this as easy as possible for you today, but here's what's really going on. It's down here, I've got a circle right here, all right? I've got a circle right here. And I'm going to draw a point from, let's say from here to up here, okay? All right, you might want to sketch that in there. First things first, I drew a line from the center up to that part where it says pi over 3, okay? And that pi over 3 is pi over 3 radians. Are you guys okay with that? You guys okay with that? Okay. Guys, on this unit circle right here, what I'm going to tell you is this. This is a radius of the circle, isn't it? Going from the center to the outside of the circle. In a unit circle, we always consider this distance to be a 1. In a unit circle, the radius is always 1. So in this whole unit circle, if I went from the center to any point on the circle, how far out have you gone? 1 unit. That's the radius, okay? Now, we talk about this unit circle as being values in terms of x and y. To get to this point up here, you guys, they're saying this point up here is 1/2 comma root 3 over what?
2.
Root 3 over 2. Well, here's the deal. That's like saying, let's go right half a unit and then up how much? Root 3 over 2. So if I would do this, if I would draw a line to go from here straight down and then over, what you really formed there is a right triangle, right?
Do we
Okay.
do that?
I'd draw that in there. Okay. And what I'm going to tell you is this. Down here, if this is the point 1/2 comma root 3 over 2, how far right did I go according to that point? A half, right? And then how far up did I go? Root 3 over 2. Okay, root 3 over 2. Now guys, if you notice in there that says that the cosine value, there's an arrow down here, it says the cosine to the right is a what? Positive value. A cosine to the left then would be what?
Negative.
A sine value is a value moving up or down, or how far above the origin you are. So a sine value above the origin would be positive. A sine value down there would be negative. Okay. Well, what's really going on here is the following. All right. I'm going to go ahead and draw that right triangle up here and just make maybe a note about this right triangle. This is kind of the right triangle that I pulled out of there. Let's see if I can finish this. Okay, there's that right triangle that we kind of pulled out of there. All right. What this is really saying, guys, is this. This is saying this is a distance of 1. This is a distance of 1/2. This is a distance of root 3 over 2. Okay, now down here, guys, it says the x-coordinate of a point on a circle is always the what?
Cosine.
Cosine. So this point right up here is written as an x comma y for that circle. And what that means is this. It's saying the x-coordinate of a point on a circle is always the cosine of the angle made with the x-axis. So the x value on any of those points will always be my cosine value. All right? Then it also says the y-coordinate is the what? Sine of the what? Okay, here's how I always remember this. When I start talking unit circle, how do I remember this? Points are always written in the order x comma y around here. Okay? In the alphabet, doesn't x come before y? Okay?
Haven't you mastered that class of picking locks yet? No. I already picked the lock of my wife. Oh, okay. Done with this too?
No, do you have one?
Up in the front right basket. I'll overtake that. I'll hang on to this one, okay?
Alright. Alright, so I was saying here is this. The cosine in the dictionary would come before what? Just as x would come before y. That's how I remember that. Now guys, what I'm really getting at is this. I want to make sure you understand, well, why are these values here? Well, what's the angle I'm really associated with on the unit circle right here? How many radians? Pi over what?
3.
Pi over 3. Now, I'm going to do some stuff here. And we can use that chart here, but I want to prove to you something about the chart here in a second. So, forget the chart for a second. Let's look at this unit circle. You understand right here that I have these values right here because this angle, isn't this the angle down here that's central to the circle? Or in other words, that angle is at the center of the circle?
Yep.
What's that angle measure in radians, by the way? Pi over 3. Or in green here, I don't know if it shows up well in your notes or not, but does it tell you how many degrees that is that we're at? So really that angle down there is how many degrees?
60 degrees.
Guys, do me a favor. Take a look at your chart on 60 degrees that I gave you. Does the cosine value of 1/2 match up with that?
Yep.
Does the sine value of root 3 over 2 match up with that?
Yep.
Okay, so I like the chart form a lot better. So forget the chart for now. Look at this right here. How do you find the cosine of 90 degrees, guys? What is the cosine of 90 according to this unit circle? Well, here's 90 degrees, so there's a point. So does the 0 represent cosine or the 1 represent cosine?
0 represents cosine.
So your value is going to be what?
0.
Well, 0. What's the sine of 270 on that circle? -1. Yep, the sine is the second value. Look at the cosine of 0 degrees. What's the cosine of 0 degrees?
1.
1. Okay. Now, guys, we start running into troubles right here. Down here, there's no rule for what? We got rules for sine and cosine, but there's no rule for what? No rule for tangent. Okay. Now, guys, right down here it says angles are always measured from the x-axis. It says recall. Do you guys remember SOHCAHTOA? What's it mean? Sine is an opposite leg length over the cosine is the adjacent leg over the hypotenuse, and finally you would have tangent as an opposite leg over the adjacent leg. And one thing that's always big in trigonometry is this. How many of you guys know this right here? Tangent's also equal to the sine divided by the cosine. Do we know that? Okay. Do now. Okay. Here's why. What was tangent's definition again? Opposite leg over what? Adjacent leg. Take a look at this, guys. If this is my central angle right here, and the opposite leg length is this length representative of a sine value or cosine value moving up and down?
Sine.
So opposite leg could really be replaced with what function? Where I have opposite leg over adjacent like this, the opposite leg is really the sine. What's this adjacent leg down here? It's the cosine. So opposite leg over adjacent leg, you could just change the wording of it because they mean the same thing to sine over cosine. So check this out, guys. Knowing that tangent's a sine over cosine, check out the tangent of 180 degrees. We would do the sine divided by the cosine. So what's the sine there? Well, it's 0, isn't it?
Yeah.
And what's the cosine?
-1.
How about 0 divided by -1 then?
0.
So the tangent of 180 degrees is going to be what?
0.
What's the next one going to be? Tangent of 90.
Infinity.
Can you have that?
It says 1 divided by what? Can you divide by 0?
No.
No.
So the point I want to make about what we're doing right here and what's in your chart, find your chart for 90 degrees. Look at 90 degrees and go over to the tangent column. What does it say there?
Infinity.
It says infinity. What that means is it's undefined. You can't divide by 0, can you?
Nope.
So anytime you see infinity in that chart, just know that this is not possible or it's undefined. Undefined. All right? So anywhere in that chart we see infinity, it is what? Undefined. Okay, 3 other rules right here. Cosecant, secant, cotangent. These are kind of important. You'd probably like to see those too, wouldn't you? Is that more gooder? I like that. What's it say that cosecant is equal to? 1 over the sine of x. What this really means is it's a reciprocal. If I had a sine value of, say, maybe 1/2, 1 over 2, the cosecant is the reciprocal of sine. So if the sine is 1/2, what's the cosecant? 2. So here's an example. And it's weird because cosecant is the reciprocal of sine. It's c with an s. And then over here, secant's going to be the reciprocal of what?
1 over cosine of x.
Cosine, right? And then cotangent's going to be a reciprocal of what? Tangent. So here's an example right here. If sine is, if the sine is equal to 3/4, if the sine of some function or some angle is 3/4, what's the cosecant going to equal then?
4 over 3.
4 over 3. That makes sense?
Yep.
Okay, so cosecant is the reciprocal of what?
Sine.
Secant would be the reciprocal of?
Cosine.
It'd be nice if the s's match the s's and the c's match the c's, but they don't. Okay? But they don't. Ready for this one? Cosine. 1/4.
4 over
Cosine.
4.
Yeah, way ahead. Secant is 4 over 1. Okay? Make sense? Alright. Hi, Emily. Emily, can I make one last pitch to you?
Hey, tell Miss Jensen I wrote hello Miss Jensen on the board.
Tracks on Monday.
Hey, tell Miss Jensen I wrote Miss Jensen on the board. Okay. I don't want you to tell her right now. She won't tell her.
That poor girl. She's not gonna do it. I think she wanted to be. She's like, okay. And in the back of her mind, she's probably thinking, Parson, would you drop it? I think she probably wants to drop me. Okay. All right. Knowing something about the basics of trig, we can find out all values of the trig functions with little other information. So what I'm getting at here is this. On the next page, if you'll take a look here, here's what we're doing. Guys, up here I've drawn a terminal side in quadrant 1. Okay. This is supposed to go from the origin out to the point 5, what? 5, 12. Okay. In this example right here, it says find the values of the trig functions. When I say find the values of the trig functions, I'm talking about all 6 of them. I'm talking about a sine, a cosine, and a tangent. The cosecant, the secant, and the cotangent. Alright? Now keep in mind, this page right here, I don't like writing SOHCAHTOA the way they do it. I kind of write it like this, if you want to do the same thing. It's the same thing, I just like to write it like this. Sine is opposite over what? Okay, cosine is your adjacent over A. And your tangent is an opposite leg over the adjacent leg. Alright. So guys, in this example right here, we're going to find the values of all 6 trig functions if a point 5, 12 lies on the terminal side of the angle. Okay. So what they're saying is this. They said, you know what, we went right 5 units and up 12 units. So I'm going to go ahead and kind of redefine this triangle right here. Looks like this. Okay, whoops. Try again. There. Guys, how far right did I have to go to get to this point? 5. Now the assumption is when I go right and then move up, what angles form down here?
Right.
And then how far up do I move? 12. So I have the two legs, 5 and 12, which means I got to find this hypotenuse right here. So it says if we knew the sides of the triangle, we could certainly find all trig values. Okay? You guys remember Pythagoras, right?
Mm-hmm.
And his
A
theorem.
squared plus b squared equals c squared.
A and B represent legs, right? So by this right here, I could go 5 squared plus 13 squared would equal your,
12 squared equals
I'm sorry, R squared, 12 squared would equal R squared. I'm ahead of myself. When they solve this right here, this is 25 and 12, which is 169. 25 and 12 squared is 169 to equal R squared. What's the square root of 169,
13.
kiddos? Okay, so that makes this radius right here a 13. All right, so by definition up here, guys, sine is what over what?
Opposite over hypotenuse.
Now, you always got a reference from an angle. Understand we're dealing with angles as they relate to circles, and all angles related to circles would be central angles. So you're always talking about the angle that is at the origin here. So what's the sine here then? What over what?
12 over 13.
If this is my reference angle, opposite is 12, hypotenuse is what?
12 over 13.
Now, I just got done with this idea of saying, hey, you know what? Well, the cosecant
13
is
over
the
12.
cosecant's the reciprocal of sine, so this will be 13 over what? Handle that? Can we handle that? How about your cosine? What's cosine?
5 over 13.
5 over 13, right? So you got 5 over 13. What's the secant?
13 over 5.
How much your tangent? Opposite leg over adjacent leg.
12 over, no.
Oh, they're already
yeah.
written for you down there, aren't they? Which means the cotangent then is going to
5
equal.
over 12.
How you guys feel about that? Pretty easy, isn't it? You guys go ahead and try one. Your point is -6, 8. So if I drew a coordinate plane like so, where would -6, 8 lie? How far left or right?
Left 6 up 8.
So up here would be my terminal side, wouldn't it? So this is -6. And this distance right here would be 8. Whoops.
Negative, what, 6? 6 squared, 10.
So, yep, 6 squared is 36, 8 squared, 64, add them together, you got 100, right? What's the root of 100?
10.
So the hypotenuse here would be 10.
Sine would be 8 over 10.
Here's your angle.
And then that one would
You
be
guys finish it up and I'll see if we agree.
8 over 10.
All right, how about your sine, kiddos? 8 over 10. Some people might choose to take 8 over 10 and do well with it.
20 or
4 over what?
5.
5. You may reduce it. I'm not telling you you have to. I really don't care if you do because either way, you have it. So if that's 8 over 10, what's this over here? 10 over 8. What's the cosine here, guys? Wouldn't that be -6 over
10.
10? Adjacent leg to my central angle. Adjacent's -6, isn't it?
10 over negative 6.
Okay, now you know I'm going quickly through this for you guys. On board with me? Okay, -6 over 10. How about the secant here, kiddos? Wouldn't that be -10 over 6? Okay, how about the tangent then?
8 over negative 6.
8 over -6. And again, if you wanted to reduce all these, you could. I'm not necessarily saying you have to, but you could. So that makes the cotangent -6 over what? All right, second page. You okay with that? All right, let's run on to this third page. I think this is the last page, isn't it? Sweet. Guys, I'm not going to get too excited about what's up here. This basically tells you all the values right here. If you're ever in the first quadrant, sine values will always be what?
Positive.
If you're ever in the third quadrant, cosine values will be. If you're ever in the fourth quadrant, tangent values will be negative. So this might be a handy dandy little chart to refer to for you. You might want to highlight this and make sure that you know it's here, but gosh, why does that do that? Make sure it's there. It says this rule tells you the sine, cosine, tangent functions in each quadrant. Okay. Down below, guys, it says reanalyze the solutions you have to a previous example. I don't think we really need to do that because we're right on. All right. It says right here we can find the rest of the trig functions when we know one of them and its quadrant. So the example I'm giving you here is the following. It says the cosine of theta is negative 8 over what? Negative 8 over 17. All right. And it says that the angle theta is in which quadrant? 2. Okay. You know, I'm just going to kind of talk about what's going on here. All right. I'm going to kind of redraw this again. Anytime they talk about an angle being in a certain quadrant, what they're really saying is this. They're saying, you know what? Here's your coordinate plane. What they're really getting at is saying, yeah, you're going to have a terminal side in the second quadrant. So from here on out, you're going to have some side that runs out there. All right? Don't know what it is, but I just know that the terminal side of my angle is going to be in the second quadrant. Is that the case right here? Okay. Now, anytime you have that, just go ahead and draw a line straight down or straight up to the x-axis. Boom. There's your triangle that's formed by it. That's not a very good right triangle, nor do I like the colors of it. No, something different, something far worse than that.
Iowa State.
Yeah, Iowa stank. Got my blood boiling now. Kidding. All right, let's change that color. Let's go. You know what? Let's go to my alma mater.
Maroon.
Yeah.
That's purple.
Minnesota?
No, it's purple and yellow. You and I. Oh,
Buckle.
Looks maroon to me.
you're lucky I'm not in my other job right now. My other job, WWE wrestler, the square root of pain. I would certainly opposite reciprocal you right now if I had the chance to.
What is the square root of pain?
Square root of pain means you are going to get a flying parabola drop right on you. And at the top of my vertex and the flight from the top of the top rope down, and I get to the vertex, I'm immediately like, you know what? Absolute value! Well, you think I'm kidding, huh? I have a mask. It's like
These
this.
just come to your
I have a
head and
mask
you
that
say
goes
'em.
like this on my face. It comes square root, boom, boom, up over my eyes.
Whoa.
Look into my eyes and you will feel the pain. That's the
Whoa.
square root of pain. All right, never mind.
Hey, tell Miss Jensen I wrote Mrs. Jensen on the board.
Ask Mrs. Jensen if she's seen it yet. Hey, ask her if she. Mrs. Jensen, did you saw the thing that Mr. Oldflag wrote on your board?
She's soft.
She's really proud that you're a good wrestler, but not so much on the human being part.
Salty.
All right, theta's down here, kiddos. Let's talk. It says right here, it says we're in the second quadrant. You have a cosine value of negative 8 over what, guys?
17.
Talk to me about the definition of the cosine function. What over what?
Jason?
Adjacent leg over the...
Adjacent over hypotenuse.
I'm going to tell you this, anytime you deal with a hypotenuse will always be a positive value. Okay? So what's the hypotenuse have to be here, kiddos, if this is the hypotenuse in the bottom?
17.
Okay? And the adjacent leg has to be 8. However, this 8 to the left of the origin is going to be what kind of an 8?
-8.
Negative, isn't it?
Oh,
All right.
17 squared.
So this time you know the hypotenuse. To find your height right here, you would have to take 17 squared, not plus negative 8 squared, but minus negative 8 squared, right? So if you went 17 squared minus,
Given.
I'm guessing that's 15.
No, it's
Yep,
not
it's
given.
given. This turns out to be 225 when you do that. So the root of 225 is this height of how much here?
15.
15. Okay, so when we run through this right here then, guys, given that triangle, understand sine. So what's the sine's value here?
15 over 17.
15 over 17.
17 over
17
15.
over 15.
So your cosecant would be 17 over 15.
Negative
And then
17 over
17
8.
over 8.
Negative 17 over 8.
15 over
Negative.
negative 8 and negative 8 over 15.
Tangent would be 15 over negative 8, opposite leg over adjacent.
Jeez.
So 15 over negative 8. So what's that make this again?
Negative 8 over 15.
So guys, if I talk to you in terms of unit circle and finding sine and cosine on the unit circle, can you handle that?
Mm-hmm.
If I say transfer that over to the chart, can you do that?
Yep.
Okay, if I give you one function, whether it's sine, cosine, or tangent, can you find the other 5 functions that are attached to it? Okay, should be pretty easy, I think. So, what questions have you guys got? Going once, twice. Okay, you guys know what you have due for Monday, and you know what you have due for Tuesday.